Hello, welcome to Chapter 5, Homework Questions 44 to 49. Question 44, find the slope of the line you would get if you graphed each sequence listed below and connected the points. Now, with sequences, we don't typically connect the points. They are just asking if you did connect the points, what would happen. So I put a graph on here just in case. We don't necessarily need it to find the answer to this, but if you want, we can kind of take a look at that. So on part A, we're looking for that change, and you can see that 5 is going to 8, adds 3, 8 is going to 11, add 3, and 11 is going to 14, and you add 3. So that represents the slope of this, which would be m equals 3. You can also see, if you plot in terms of term 1 being 5, term 2 being 8, term 3 being 11, and term 4 being 14, you have your slope triangle, 3, 1, 3, 1, and 3, 1. So if you did connect the points, that's what it would look like. On B, 3 to 9 is plus 6, 9 to 15 is plus 6, so your slope would be 6. On C, 26 to 21, you're adding a negative 5. And on the next one, you're adding a negative 5. So your slope would be negative 5. And then on your last one, D, 7 to 8.5, you're adding 1.5. 8.5 to 10, you're adding 1.5. So your slope is 1.5. Question 45. For the line passing through the points, negative 2, 1, and 2, negative 11, calculate the slope of the line. So we are finding the slope. The slope represents the change of y over the change of x, so delta y over delta x. We're going to take the difference of the points, negative 11 minus 1, that's your y. So negative 11 minus 1. And then for the change of x, we will go 2 minus negative 2. So 2 minus negative 2. That's negative 12 on top. And then 2 minus negative 2 is not 0. It's minus a negative, so it's plus 2, which would be 4. So your slope is negative 3. So on part A, our slope of the line would be negative 3. For B, we're trying to find the equation of the line. Well, we have the rate of change. Now we need the starting value. So we can find the starting value by using our equation y equals mx plus b. Plugging in the values that we know. We know the slope is negative 3. Pick one of the 2 points that were given to us and plug those values in. So y is 1, m is negative 3, x is negative 2, and then plus b, and we can solve for b. So negative 3 times negative 2 is 6. Subtract 6 from both sides, get b equals negative 5. So the equation is y equals negative 3x minus 5. Question 46. Allie is making 8 dozen chocolate chip muffins for the food fair at school. The recipe she is using makes 3 dozen muffins. If the original recipe calls for 16 ounces of chocolate chips, how many ounces of chocolate chips does she need for her new amount? Allie buys her chocolate chips in bulk and can measure them to the nearest ounce. Alright, so let's look what we're comparing here. We have Allie's making 8 dozen chocolate chip muffins. Her recipe that she is using only makes 3 dozen muffins, and the original recipe calls for 16 ounces of chocolate chips. So how many chocolate chips does she need for her new amount of 8 dozen chocolate chip muffins? So what I'm thinking is maybe we can set up a proportion comparing things. So we have 3 dozen muffins that we're making, and with those 3 dozen, it requires 16 ounces of chocolate chips. That should be equivalent to what she's going to make for her 8 dozen. And then what we don't know is X number of ounces of chocolate chips. And so we can solve that by multiplying both sides by 16. That would leave us with 3 is equal to, I'm going to get rid of the units. The 16 would cancel, and we get 3 is equal to 8 times 16. and that would be 80 and 48, so 128 divided by x. And now we need to multiply by the x, and that would be 3x is equal to 128. So both sides get multiplied by x, that's why the x is with a 3, and then it cancels out on this side. So now divide by 3, and x is equal to 128 divided by 3 would be 4. And it looks like it's just not gonna go in exactly 42 2/3, but we can't buy 2/3 of an ounce. So it does say Allie buys her chocolate chips in bulk and can measure them to the nearest ounce. So we're not going to say 42 2/3 ounces for 8 dozen. We'll just round up to 43 ounces. And so make sure you answer that question. And like I said, we are going to round to 43 ounces based on the information at the end of the problem there. So Allie needs 43 ounces of chocolate chips for her 8 dozen muffins. Question 47. The area of a square is 225 square centimeters. Make a diagram and determine the length of each side. Then we're going to use Pythagorean Theorem to find the length of the square's diagonal. So the first thing is to get our square here and see what we can come up with. We know the area is the length times the width, but because it's a square, the length and width are equivalent. So we can use substitution. Whoa, I didn't know I could erase the square. Substitution and make this both L, so length and length. So L times L is equal to 225, or L squared is equal to 225. So what number times itself gives you 225? There's really two numbers that could give you this. That would be negative 15 and 15, but the negative 15 doesn't make any sense because we're talking about a distance. So determine the length of each side. The length of each side of the square will be 15 centimeters. Alright, so the length of each side of the square is 15 centimeters. Now we need to use Pythagorean Theorem to find the length of the square's diagonal. So the square's diagonal would be that right there. Once again, we know that each side length is going to be equivalent. So if you remember with Pythagorean Theorem, is a squared plus b squared is equal to c squared. Remember, a and b are the sides of the triangle. And then c is the hypotenuse, or the longest side. Alright, so if these are equal to 15, then we will take 15 squared plus 15 squared is equal to this diagonal, and we'll just call it C since it does represent the hypotenuse. So 15 squared is 225 plus 225 is equal to C squared, or 250, not 250, it's not very good math there, 450 is equal to C squared. So what number times itself will give you 450? Now this is not as easy as the 225. There's not an exact number that does this. That is a whole number. So what we can do is to undo the problem. Since it's being squared, we're going to take the square root of both sides. So if you take the square root of 450, you approximately get 21.21 centimeters for C's value. So the length of each side of the square is 15 centimeters, but the length of the diagonal for part B is approximately 21.21 centimeters. And once again, there's the answer. The length of the square's diagonal is approximately 21.21 centimeters. Question 48. Refer to the sequences C and I in problem 541. How are these two sequences similar? And then the numbers in the sequence in part E from problem 541 are called Fibonacci numbers. They are named after an Italian mathematician who discovered the sequence while studying how fast rabbits could breed. What is different about this sequence than the other three you discovered? So we need to go back to question 5-41 from the core problems and then look at C and I. So here are the two problems from the core questions on 541, C and I. And so during class, one of the things that we had talked about is these grow a little differently than our arithmetic and geometric sequences. So neither one of these is arithmetic or geometric. One of the things that we also noticed when we graphed it is that it wasn't, it was the shape of a, especially the second one with the I, was the shape of a U. So that kind of indicated that it was a quadratic. So those are a couple of things that we noticed in the problem. Also how it grows, how you see you add 1, and then you add 3, and then you add 5. Whereas the one below, you subtract 6, you subtract 2, you add 2, you add 6, and then you add 10. Maybe not as easy to see on that one, but if you take a look, then the difference from the next one is you add 4, you add 4, and you add 4 all the way. So it's that second difference that you're looking at that is actually constant. So there's a couple things that you could have wrote down as to how the two sequences are similar. And then, so this was part A here. And then part B, the numbers in the question E from that same section. Let me write that down. All right, these are called Fibonacci numbers. And so what is the difference about this sequence than the other three you discovered? Well, it's not arithmetic. You're not adding to get to the next number each time. You're adding, in this case, 0, 1, and then 1 again, 2, 3. So it's not like the ones we just talked about on C and I. It's not a constant, as in linear arithmetic, and you're not multiplying to get to the next one. So it doesn't have those things in common that we have talked about. So there is no multiplier. You're not adding a constant number every single time. So definitely it's a little different than the other three that we had talked about. And another thing I just noticed is that when I went to do the differences here in red, 0, 1, 1, 2, 3, look at how that relates to the sequence itself. It doesn't have the 0, but it's 1, 1, 2, 3. If we expand this one more, so it'd be 5 plus 8 is 13. That's the pattern there. And then once again, the difference between 8 and 13 is plus 5, which still matches up with that sequence above. So that's another thing that you could have talked about in terms of how it is growing. Question 49. Chelsea dropped a bouncy ball off the roof while Neri recorded its rebound height. The table below shows their data. Note that the 0 in the bounce column represents the starting height. So it started at 800 centimeters, and then it shows the bounces from 1 to 5 from there, and it goes all the way down to 60 centimeters. So part A wants to know to what family does the function belong, and explain how you know. Well, we've done this problem in the core problems in class. So we know that this is going to create an exponential function, so exponential. And we know that because, one, what we've done in class, but also there's going to be a certain ratio that is going to get multiplied to get to the next one. Now, it might not be exact on this one just because of them recording it, and it's not going to be exact for that, but it should be close to something. So we do know it's exponential because the ratio of one rebound to the next is going to be some constant value. Part B, show the data as a sequence. Is the sequence arithmetic, geometric, quadratic, or something else? Well, we know because it's exponential, it is going to be geometric, because we know that there's going to be something that is multiplied. Let's see if we can figure that out. So if we want to figure out, what that that multiplier is, we can work backwards. The question is, 800 times what value should be equal to 475? So we just work backwards. We divide the 475 divided by the 800. And if we take 475 divided by 800, we get approximately 0.59. Okay? And so we could do this a couple of different times. We could also find the next one, 290 divided by 475. And 290 divided by 475 is approximately 0.61. So it's a little bit higher on that one. And we could keep doing this, but once again, that's going to be very close to 0.6 on each of these. And so we know it is somewhat geometric. It's not exactly, because like I said, they are recording the heights, so you're not going to have the exact precision, but it does represent geometric for the most part. And so once again, I said geometric because it has a multiplier of approximately 0.6. Now, some of you might say it's neither, just because it's not exact. I went ahead and said it's geometric based on the information, knowing that we've done this in class, and if we could be very precise or exact, that it would work out exactly.